Good morning, everyone. I know it's a Friday, and we're looking forward to the weekend. And I'm going to talk about, me and Ameya are going to talk about how we automated code maintenance and how you can too. So a little bit about ourselves. I'm Gautam. I'm a co-founder at the startup Guitar. Previously, before starting Guitar, I was at Uber for 10 years, kind of saw it scale from the very early days. And saw just a lot of tech debt pile up. And hyper-growth phase, we just kind of, committed code, didn't really think what was going to happen after is the problem of the next person. I was that next person usually, dealing with the debt. And lots of crazy scaling and experiences growth. And firsthand, we have a lot of experience solving this problem at Uber scale. And my passion is to improve developer experience with all the things that you use every day.
Hello friends, I am Ameya Ketkar and I am a software engineer at Guitar. My passion is deleting lines of code. My fame to claim is that I have deleted over 500,000 lines of code when I was employed at Uber. And how did I do that? I developed my tool to delete lines of code. So yeah, in this talk, I'll be introducing you to that tool. I got my PhD from Oregon State in program analysis and code rewriting. And yeah, I'm very passionate about developer tools. Off to you, Gautam.
Thanks, Ameya. So before we get started, I wanted to kind of start with the key takeaways I want you all to go with. So I'm sure you write a lot of code. You might know that code maintenance takes a ton of time. Right? And the current approach of throwing process and more engineers to the problem is actually not sustainable. And teams are smaller than ever, process is getting more complex with lots of different stacks that developers have to maintain. It's very difficult to do this without automation. So automation is key, but however, it's actually really hard to do across all the different languages at scale. And we actually did a lot of this stuff back at Uber. And we are basically now at Guitar taking on the challenge of automating the code maintenance, and we're building this out so that you folks can use it as well. So if you folks have seen the recent Kotlin Conf announcement, who's seen the Kotlin 2 announcement here? Who's excited for using it in your code base? I expected more hands, actually. So there's a lot of cool stuff they announced, and I was just talking to some colleagues, like, hey, what do you think about Kotlin 2? They're like, yeah, the compiler is amazing, I want to use it. And I'm like, okay, great, did you actually upgrade? Who's upgraded to K2 so far? Only 2, okay. So I can imagine, like, it'll be amazing to have, but it's not easy to just, flip a switch, right? Because the moment you try to do it, you can deal with these kind of problems. Broken code bases because of APIs that change, version conflicts with third-party dependencies that are transitive, issues with your favorite IDEs, I'm not going to name them, and plugins and build systems, and all the compiler plugins. And if you're doing multi-platform, you have to really worry about, okay, how does the app actually now work on all the other platforms that are built for it? Right? So it's not a simple thing to just flip a switch. Right? And if you just think that K2 was one issue, but you got to really understand that as developers, like when we measured this back at Uber, we saw around 30% of time was spent on code maintenance. So that could include anything from patching security issues to dependency management, as we just discussed, implementing best practices, or cleaning up stale feature flags. Who's doing feature flagging here? Pretty much everyone should. If you're not, I'm very worried about you as a mobile developer. And if you're writing a lot of features and you're shipping flags, this is something I don't think a lot of people realize. You're usually adding debt. Before flags, you would delete the code and or have a branch, but now we just throw everything in the same code base and hope and pray one day someone's going to come and clean it up. And putting it into perspective, 100 developers, if you have 30 of them maintaining code all the time, that's a lot of time lost, a lot of business value lost. Developers are just unhappy because this kind of work is rarely rewarded, and it's not easy to do. And in general, it also scales. The more developers you have, or even the less developers you have, your team is always kind of catching up to the latest. You might think, okay, maybe I just ignore this problem and it goes away, or I'll deal with it some other time, right? And that also is not good, because when you ignore code maintenance, you have all of these issues that pile up. You have good code quality, because now your apps become unreliable, your apps become janky or slow because you're on an older version of something. Security incidents, who's been through the Log4j upgrade here? Wow, you already upgraded everything, okay. So I got a call. I was on vacation, and my boss calls me, "Hey, this Log4j security incident just dropped. Can you just stop what you're doing and come back and do this?" I was like, "Wow." It's really scary when these kind of things happen because we don't keep things up to date all the time, right? And outdated tech can be really problematic in many ways. So even just having the cognitive overhead of multiple versions in the code base, this is what happens usually. It's hard to upgrade, so I'm just gonna upgrade it in the place I need to. And then some poor developer comes by later, and they're like, okay, why are there 5 different versions of the same library, right? And then to actually fix this, usually we add process. And the more process you have, the more unhappy developers become over time as well. Talking about process, some of the things that we've seen to tackle this, usually you have dedicated sprints. Who has dedicated sprints or hackathons to like fix tech debt? Wow, that's a lot of people actually. So you can have dedicated sprints just disrupting your feature velocity. And you can also have like these giant hackathons that are company-wide and like, hey, let's get everyone on board, let's go fix this stuff. And that works usually, and it's typically a Band-Aid fix. And if you just ignore it, eventually it blows up and you have a Code Yellow or Phoenix event, whatever you want to call it, take your flavor. And the business just can't ship new features, and you have to be all hands on deck, stop everything, and get it unblocked. But the actual key to get this under control is automation. So unlocking that 10% of developer time, increasing developer happiness, and shipping more features. But all the tools that we have for automation are not sufficient today. At best, we call them as like nagging as a service. They create tickets or Jiras, and they're like, hey, go fix this. And if you don't, the CTO is going to come scream at you, like, why is it not done yet? Not very well integrated into your tools, in your tool chain. So they might be just creating tickets in your task management, but not really inside the IDE where you need them to be. And not cross-language. Like it or not, today's code bases are polyglot. They have a mix of mobile apps, front-end, back-end microservices, data pipelines. You need to be able to cover all of these scenarios and do it really well. And that's exactly why it's a hard problem, because doing it reliably at scale with a lot of accuracy so you don't get false positives, nothing's worse than a linter that screams at you and you're like, hey, this doesn't make any sense. I don't trust this tool anymore. And making sure that you actually cover all the use cases so you don't leave something behind that the developer has to pick up. And performance at scale. And to kind of show you why it's actually so hard, we'll have a case study that Ameya is going to walk you through next.
Thank you, Gautam. Yeah. So, yeah, like Gautam explained, automated code maintenance is really hard. And now let's zoom into one of the examples to understand why it is so hard. So, feature flags. So if we all use feature flags, we know why they're useful, right? You can incrementally roll out features, you can do A/B experiments, you can mitigate prod issues for your mobile apps, and so on. But what happens is that over time, these feature flags get stale. So basically, your feature flag rolls out to all its customers, or your experiment is completely scrapped, and now you no longer require that feature flag. Nor do you require the code related to the feature flag in the code base. So what we do, like Gautam explained, we have these manual cleanup drives, dedicated sprints, fix up, and we try to clean up all of these feature flags. But this is unsustainable because we can't just keep having this dedicated sprints again and again. And because that does not happen very often, there is like this tech debt that keeps piling up. So now, yeah, let's look at some code. Yeah, fun stuff. So this is a simple. This is a simple piece of Kotlin Java code. At the top, you can see a Java interface that declares a Boolean method is new banner, and let's say that's our feature flag function. Next at the bottom, there is some Kotlin code. That is using this Java interface, and it's checking whether new banner is set to true or false, and based on whatever is its value or the state of the user, it either displays the new banner or it displays the old banner. And then at the very bottom, you have the Android components, which are the banners themselves. So now, let's say that this feature flag, new banner, has been released to all your customers, and like now, you don't require old banner at all. So what would you do, right, as a developer? Let's experience it as a developer. So you would say that, okay, let's find new banner and delete the function that corresponds to it. Boom, you delete it. Next, you look up for all the call sites of this function. So you look up for is new banner, and you replace it with true because it has been released to all our customers. Now, next, what do? You have to simplify this disjunction. So true or something becomes true. Now you have this if true, do something else, do something else. No-brainer, we don't require this if condition at all now. So we delete this if condition and just preserve the consequent. And now you can see that we have two statements under a return statement, which is like unreachable code. Even that has to be deleted now. So you go and delete the unreachable code. And finally, you find that, oh, after all of this deletion, there is some unreferenced code or like unused code, like this old banner, Android component. So you go and delete that too. So yeah, what you actually saw right now is what a compiler does when it tries to optimize code. And this is what we expect our developers to do as a part of feature flag cleanup whenever we have these dedicated sprints or these fix-it weeks and things like that. So, and it doesn't end here, right? You have an Android app. So you do this in your Android app, in your Android code base. You have a Go backend. So you do the same changes, like you need to remove old banner from your Go backend. You need to remove it from your web frontend. You might be using JavaScript, Ruby, and you also need to remove it from your Swift code base. And now we can see why it becomes so tedious and hard for developers and teams to, keep on continuously cleaning up these stale feature flags. So the problem is that, it's not a problem. It's a good thing that we are adding more features. So when we add more features, we add more flags. So like at companies at like Uber or some other companies that I've talked to, we've seen that they introduce like 500 flags each month. And then like a huge chunk of these flags are going to get stale at some point in the time. And then what happens? You have to do more maintenance tasks. So it's like more features, then you do more flags, and because you do more flags, you do more maintenance, and then that has like this negative impact on like your dev velocity, because now your developers are spending time cleaning up flags rather than adding more features. What do you really want is that you want to add more features, you want to add more flags guarding those features, but you want it to be cleaned up automatically. You don't want your developers to clean it up. You want like all of this to happen automatically. There's like one more problem is like developers are not just doing feature flag cleanup. Like feature flag cleanup is just like one of the one maintenance task. You can do things like migrations, like at Uber we did PowerMock to Mockito migration, or we did like a bunch of internal migrations for our libraries. You can do security fixes, like for what Gautam was called from his vacation. And you can obviously do cleanups like I showed you, the feature flag cleanups, and there are like many kind of dead code cleanups that you can do, and that we have also done. But however, all of this is easier said than done. So the idea, so as developers, so let's say that you want to go and automate a refactoring like that or a migration like that. What do you use? Most people will go to like using grep, sed, or like use their IDs, find and replace. Some more geekier people will be like, no, but I can do structural find replace in my IntelliJ IDE. And they're going to use the structural find replace. And then if you're like want to do more hardcore stuff, you're going to be like, okay, I'm going to write my own detect plugin and then, figure out, like, do this migration and code rewriting using detect. So let's look at the first category of tools that I just showed, which is the regex-based or text-based tools like sed and grep. So the beauty of these tools is like they're polyglot. Like forget polyglot, they don't even require a programming language. They can even work on your text files, right? It's just find and replace. So they work across all file formats. They're also very performant. Like they've been around for years. So there have been many new evolutions and variants, like the latest ribgrep. It's like blazing fast. It's also easy to use. obviously, because there's so much documentation around it. You can ask ChatGPT. ChatGPT knows everything about grep sed, and it can easily, tell you how to use it. However, the problem is that if anyone here has tried to match expressions using regex, they know how hard it is, or like how not expressive it is when you want to match like programming language constructs using regex, because of variation of formatting, because of syntactic variations, and so on. So you go to the next level of tools, which is the syntax-based tools. Now these syntax-based tools are also polyglot, like they work on parse trees. All programming languages can be parsed, so they work across most languages. It's also like an emerging class of tools. So they're like slightly less performant, like they've not evolved so much until now. And like the bigger problem here is that to use these kind of tools, you have to parse the code, and parsing is heavy compared to like what their regex counterparts can just string match. And they're also slightly easy to use, because most of them have like this declarative syntax and some documentation. So I guess it's easy to use, but like their expressiveness and applicability is slightly more than regex-based tools, because you can match code more easily compared to regex, so it's more applicable. And finally, we reached on the other end of the spectrum, which are these hardcore language-specific type-based tools. So for example, you have detect for Kotlin, you have error-prone for Java, and so on. Like these tools are very expressive, and many program analysis stuff can be like expressed here. But there is a problem. Like these tools are language specific. Like they are so ingrained with the compiler and so ingrained with like the compiler and all the language infrastructure that each of these frameworks work only for that language. So detect works only for Kotlin, error-prone works only for Java. And another problem is that they're also very hard to use. Like, has anyone here had experience writing a detect or a error-prone like kind of a plugin? Yeah, it's pretty hard. Like the visitor pattern gets nasty. It's very notorious to do all of that. So you need to have some kind of a experience to write those kind of fixes in these systems. But yeah, like I told you, they're applicable. One trivia is like, all your IDE plugins, they use these kind of systems to write refactorings like extract method and inline and things like that. So there are so many options when I was at Uber, and we had like, so many tasks to do. Each one had its own strength, own weakness. So what did we do at Uber, and what are we doing now? We made our own tool. Yeah, seriously, we just thought that we'll make our own tool. We spent 4 years developing this tool. We had to innovate. You see, the problem is that at Uber we could not, or even now at Guitar, we could not like have one tool dedicated to one language, and which is working on the type-based systems and things like that. So what we had to do is like we had to take the ease of use and performance of the syntax-based and regex-based systems, and get the expressiveness and applicability of compiler-based approaches and use it as in our polyglot Piranha system. So basically, Polyglot Piranha is like this novel framework for expressing refactorings and code rewrites. We created this when we were at Uber, and now we actively maintain it. So it's not just it's like a balance between engineering and research, because there was a lot of innovation and groundbreaking ideas that went into developing this tooling, which was also recognized at PLDI, which is like a top-tier academic conference where our paper or this domain-specific language was published and appreciated. So, yeah, pretty cool. So using all of this infrastructure and Polyglot Piranha tooling that we developed, I applied it when I applied it, and we managed to merge over 1,800 PRs. And these 1800 PRs were doing things like feature flag cleanup, migrating from PowerMock to Mockito. They were doing some internal library migrations that we had to do. One cool thing is like only only less than 10% of the changes were manual. Most of greater than 90% of the PRs required no request. So it was just like developers got the PR, they stamped it and landed it. This led to like, deletion / migration of over 500,000 lines of code. We carried this experiment for 6 months. And if you do some hand-wavy eyeball calculations, this is equivalent to the effort of 29 developer team, a team with 29 developers. So now Gautam is going to show how you can do it too. Off to you, Gautam.
Thanks, Ameya. So if you saw the tech and you're like, cool, how do I use this thing? This is, of course, the open source project, but once we started Guitar, we've taken it to like a really next level of performance, language coverage, and I'll kind of show you what we do now. So fundamentally at Guitar, we automate code maintenance. We don't create Jira tickets for your team. We straight up just give you the PR, and we make sure it's green before we give it to you, so you don't have to spend time, figuring out what's happening on CI. And we automate the code cleanup. If you're using GitLab, we also generate like MRs, so we're not like tied to GitHub in any way. And you just review it, and then you merge it, and then you go about your way. And if you're feeling confident enough, you can even auto-merge it if you're one of those kind of people, but I wouldn't advise that. Like, hey, the bot's responsible for this change. And now that you know that you can actually create PRs, like, okay, how does it actually work? Where does it actually get the information to clean up the flags or do other kinds of code maintenance? So we integrate seamlessly into all the tools that you use. So I've been doing tooling for 10 years, so we wanted to make sure the developer experience is rock solid. We integrate with all your IDEs, your CLIs, your tools which you emit or create these Jira tickets, right? And they might have like different signals. And you can also just invoke it by yourself through the bot. And we take that input, that exhaust from your system, we run the analysis, we run the cleanup, and then we post back a PR on your source code hosting platform. And we are polyglot by nature, so when we generate PRs, if you have multiple languages, if you're in monorepos, we don't have an issue with scale. We worked at that scale, we solved this problem there. So Kotlin, Flutter, Dart, Java, Swift, React Native JS, even on the back end, all of these frameworks we support. And beyond just polyglot, there's a lot of other stuff that we built. So this whole thing that we built at Guitar is a very intelligent platform. We have taken a very strong foundation of compilers. So these are always going to be deterministic, the transformations. And on top of that, we built in intelligence about the framework. So your dependency injection frameworks, your unit testing frameworks, or your instrumentation frameworks. And then on top of that, we put a little sprinkle of AI, which you have to these days. But the AI is very specialized to actually understand the transformation in the code. The actual transformations themselves are driven through deterministic compiler techniques. So it's not your garden variety of AI. It's very specialized to this task, and that's how we're able to scale to arbitrary code bases with varying code patterns. There can be a lot of spaghetti code. We like to eat spaghetti every day. So we got this. And beyond the feature flag cleanup that Ameya showed, we also have migrations. A bunch of them we did back at Uber. We're also working on security fixes for common issues in mobile apps as well as backend. So we have a lot of different automations planned. So if you're interested to talk about these kind of migrations that you might be facing or any sort of like issues that you want us to help fix through automation, come talk to us. We're right outside, and we can chat. So the key takeaways, just want to repeat, is that code maintenance takes so much time. I think a lot of us agree with this. Automation is really key, but it's very hard, right? So we experienced this back at Uber, and we had to innovate to get ourselves out of it. And at Guitar, we're taking on this challenge, and we're building this automation and giving it to you as a service, now that we have solved it. If you'd like, you can also scan the code to get early access. It's not open beta yet, so if you're curious about trying out the platform and running some cleanups, you can scan to get access. You can connect your repos. If you need like support in IDE, come talk to us. We can work with you and like figure out what works best for your team's needs. And yeah, thank you so much.